Welcome to Ask and Learn.
All right, so for this one, you have two concentric spheres. This one has a radius r1, and then this one has a radius r2. And then the inner one, I'll call it r1, q1, is 4.00 times 10 to the minus 8 coulombs. And then the charge on the outer is 2.00 times 10 to the minus 8 coulombs. And then the goal is to get the electric field at an R within here and then an R outside of it. So for case A, R is equal to, what was it again? 12 centimeters and 20 centimeters. So I'll just go ahead and write it in meters, 12.12 meters, and then I'll write out B, R equals 0.2 meters. So through Gauss's law argument for, why? What happened? Okay. So for Gauss's law argument for this inner one, you can draw your Gaussian surface, ask what's inside, and then use that to evaluate Gauss's law. And the problem would basically go the same as if this were the inner charge was all concentrated at the center. And so it would proceed in the same way that you would derive the field for that, which is a familiar result, 1 over E. E is 1 over 4 pi epsilon naught times Q1 over R squared. And so you can totally ignore what's going on with Q2, again, by Gauss's law argument. And so when I plugged in all of these variables, I obtained 2.5 times 10 to the 4 newtons per coulomb. And for B, now you're outside the sphere, so your Gaussian surface is going to be, I'll just draw like part of it, but it kind of extends all the way through. And so for R is 0.2, you just do the same thing, except for now you do E is 1 over 4 pi epsilon naught times the total charge, because all of the charge is now enclosed. Yeah, it kind of took me a while to feel convinced that you could totally ignore the outer charge when considering the field inside. But it does come from a Gauss's law argument. I mean, you can also prove it probably using Coulomb's law too, but it's a little messier. Anyway, when I plugged all this into a calculator, this is what I got, 1.35, 10 to the 4. So even though you're including more charge, you're further away. So the effects kind of make the field less.